My name is Sergei Shutov, and I'm a developer from InterSystems Australia office. And this presentation we'll do together with Ben Kolb from InterSystems, who will join me a little bit later on the stage. And we will talk about modernizing traditional applications. So I understand that's the last presentation, last session, and I will try to make it a little bit more energetic and less slides and more tinkering around in terminal. So it will be a kind of technical and hands-on presentation. But before we start, we all know the first rule of software development. If it works, don't touch it. So the first question we should ask ourselves when we're talking about modernizing our existing application is why are we doing that? And it's very important to answer this question to understand what our options and what our solution to modernization would be. And to help us, those two nice fellows, one is Ward Cunningham and another is Martin Fowler. They're pretty well known in software development world. One is inventor of Wiki, and another one is author of a very nice book about the software refactoring. So one of them came with an idea and another one promoted it, the idea of technical debt. So when we are talking about technical debt, there is no real definition. Everybody understands this term in their own way. But the idea of technical debt is stuff that prevents you from adding the business value into your application. So with the idea of technical debt, you can create all the nice graphs, and you can talk to your business owners, to your boardroom in terms that they understand. So with the technical debt, well, first of all, if we don't think about technical debt, it usually increases rather than decreases, like the normal debt you will have with your money. And the idea is that technical debt is everything that prevents you from working effectively. So it may be some inefficiencies in your code. It may be use of some complex outdated structures. It may be a very complex code that you have to spend a lot of time trying to understand to make changes. And so the more debt you have, the more interest on that debt you will have to pay. And then once you start decreasing your technical debt, you will be able to add more and more business value into your application. So with that in mind, let's talk about how we deploy and how we actually build the development process for our applications. This is a slide that Ben Speed came up with last year on Global Summit. It describes the best development practices. So in his idea, and well, this is not the only diagram you can think of when you're talking about the development practices. But pretty much you start from the bottom, and then like a ladder, you climb on the top. So you start with just authoring code in your studio atelier. Then you add a source control into it so that every change in your code will be audited and saved in your source control system. Then you add automated testing, you add automated installation, and that together allows you to do the continuous integration, which is pretty much build your system every time you make a change into it. And then after that, you can do automated provisioning using, for example, Docker, when continuous integration system puts the stuff that it builds into container automatically. And this is a really nice process, and if you want to learn about it, there is a separate session which will happen tomorrow and on Wednesday, presented by Ed Lebeduk. He will describe exact that process. What we are going to talk about today is quite a much more simple process. So it is understandable that not everyone can use source code control, for example, because to use source control system means you have to redo all your, rebuild all your software development process on the whole company. Sometimes it's not possible or not desirable. What containers actually allow you to do is skip all the middle stuff, which is awesome. And if you are starting with the new project, or if you are in the place where you can introduce and use a source control system, well, you should go for it. But you don't have to do it. So you can modernize your application to use containerization without actually relying on a source control. And today we will talk about how we can achieve this. So just a couple of words about containerization. I think by now you should pretty much all be aware what the containers are. But in terms of deployment, if we will compare the traditional architecture with the containers, I really like this picture. So with the traditional architecture, to make any changes into that thing, you should pretty well know what you are doing. With the bunch of containers, it's much simpler. So with containers, you have a standard packaging with the Docker images, standard distribution process with the image registry, and standard execution process. So it doesn't really matter what's inside your container. All the outside of your container is exactly the same for every container that you may encounter. So pretty much what we are doing is we are hiding all the difficult things about your application into this shell, which works exactly the same on your premise and in the cloud. And there is this nice thing which I actually borrowed from somebody else. So you pretty much build, run your containers with code and data, and from outside, it actually looks like this box with standard inputs and outputs and configuration. So that's pretty much what we are going to do today. So we are going to take our traditional app and build a container around it. What this allows us to do, like this modernization pathway, so we're coming from existing application, converting it to container, and that allows us to use all the modern infrastructures, all the cloud providers, all the modern methodologies with automation systems. And we can start using the microservice architecture, which is described again in the separate session. There is a tearing apart your monolith experience lab tomorrow and day after tomorrow. So if you are interested in microservices, like the very next step after what we've done today, please come and enjoy the experience lab. So what are the prerequisites for using Docker, for using containerization? Just actually two of them. The first one, your application has to be able to run on Linux. Because, well, we pretty much only provide Linux containers for Iris. The second is that you have to divide your application into immutable part and mutable part. So a mutable part is usually your code, some of prefilled code tables, some of prefilled globals that you will ship together as your installation bundle. All the user data is usually a user database, but sometimes it's not as easy. So sometimes some of your code is generated in your application, so you will have to map all the code that is being generated and has to be preserved into this user database. Sometimes you will need more complex installation scripts. So for example, you have some pre-filled code tables that user can change afterwards. So that means that, well, you have to ship some standard stuff, but then you have to preserve it. So it's not like black and white all the time, but you will have to divide those two types of data in your database for it to work. So with that in mind, let's go and try to modernize some applications. First of all, I wanted to show you the good stuff based on track care, because I'm a track care developer, and track care, well, it is impressive, but the downside is that it is huge, so it takes a really long time to do anything with that. So what I did is I actually created a new EPR, which is the electronic pet record, not the patient record, with some legacy vibes in it. So it's this kind of terminal monotype font web page. And it can do all the fancy stuff like search for pets and do a schedule, registers your pets. One of interesting features of this particular EPR is that it has, oh, I logged out, sorry. It has this nice pet of the day feature, which actually relies on a third-party application to print a nice poster for the pet of the day. So let's say our pet of the day is some Fido. And then once we press go, it will print this nice banner using the third-party applications, actually call out from cache into some shell script. So let's go back and have a look at where it is running. So currently it runs on my Apple macOS cache instance at 2007.1. And I can develop stuff locally in my atelier. So what I want to do is create a container with my application in it. To do that, I will use this, let me make it full screen. So this is the Jupyter notebook. And pretty much what it does is it just executes those things in a terminal. So for example, if I will execute the date, it will print the current time. And just for you to be sure that this is not just smoke and mirrors, it's actually running there in terminal. So I just want to show you that I have, at the moment, no Docker images, no Docker volumes, no Docker container running. So pretty much that's the stage you will have your environment in once you install Docker. It's just totally empty. The first thing that we have to do when we want to start using Iris in a Docker is download the Iris Docker image from WRC. In future, we will provide this image from the standard Docker repository, so you will be able to just type Docker pull InterSystems Iris. But now you have to download it manually and do this docker load command. It takes a little while because it will unzip this image and then load image into my Docker image, local Docker image repository. So if I now issue the Docker images command, you can see that I've got this Iris container while before it was empty. The first thing we want to do once we downloaded the image is to retag the image with some name that we can control. So in this case, we can decide when we want to go to like a new iris version. So we will just retag another iris version as JS18 demo stable and rebuild our images, and it will use the new iris images from here. And that will not require any changes into our Docker configuration. So just retag another iris image with your iris table, and it will use that image instead of this one. So if we will look what images we have after this comment, you can see that we now have 2 images here, but it actually is the same image ID. So you can tag this image as many times as you want. Now, that's good. So now we have loaded the standard iris image. Now we want to build an image with our application. To do that, we will need a few things. The first one is the build file. The build file is the standard %installer file, which probably some of you are aware about. But pretty much in Cache and in Iris, we can define an installer manifest. And in this manifest, it's quite simple. It doesn't do much. It will just create a new namespace based on the parameter. It will add a new application database from this directory, and it will not create it. So it will expect me to put some existing database into there. And it will create a new CSP application with this, well, very obvious stuff, authentication methods equals 64. It means that it will not ask me password when I will try to, go to this application. And then there are 2 standard methods for installer manifest. The first one is a method generator that, based on that XML definition, will generate the actual code that will change my database configuration. Another one is the entry point, which will just call that method with parameters. So I will write down this file, build.cls. Another one is the Docker file, the Docker image configuration file. This one probably will be new for many of you. There is a lot of documentation how to create those image files, but pretty much for our application, we need to base our image on this JS18 demo / iris table. So usually when you create a new image, you base it on something else. It can be like an Ubuntu operation system, or it can be image with Node.js in it. In this case, it's an image with iris in it. So I take this standard iris image. I will copy all my dependencies into this image. So I'm using this text utility, which produce nice banners for my pets of the day. It is a little bit different from how you usually would approach using like Linux operation system. So you will usually do apt-get update, apt-get install, stuff like that. With containers, we don't really care about packaging, because we will never like update stuff in container. We will never remove stuff from container. All container can realistically do is start itself and stop itself. And when we want to change something, for example, we want to add a new version of that text utility, instead of updating existing containers, we will just remove all containers, rebuild new containers, and add and start container with a new version of that utility. So we add our dependencies. We can add some configuration for those dependent of the dependent software. Just my software is so simple, it doesn't need any configuration. And then we add existing database with our application code and application immutable data. Then we add this build file, which we will run to do the database configuration. And then we need to start Iris, load our installation file, run it, and then stop Iris. So pretty much that bit is our configuration. And again, this is a very simplistic approach. So I will take my existing application database. As you can see here, I am just copying my database from its existing directory into my current working directory. If you're using source control tools, here you can actually load your source code and compile it using script like that. Another interesting feature here that you might remember and then use is that I'm starting Iris in the emergency mode. So in this way, I don't have to specify my username and password for Iris, because by default, it's you can't log into it. You have to reset your password when you are trying to log in. But if you are starting it this way, you actually provide a temporary username and password that you can use to call InterSystems Iris just in this session. So I'm writing down this file. I'm copying my existing database into the working directory. And well, don't do this at home, right? Because it's a little bit dangerous to do that without stopping cache. I just don't want to waste our time stopping cache and starting cache before copying the databases. So I'm copying my text utility into my working directory. And I'm issuing this docker build command. So it will build the container based on my current Docker file in the current directory, and it will tag it as JS18 demo /barcare latest. So if we will look at the output of the container, every definition actually creates a new container. So we will have a few containers here, with one with my text utility, one with my database, one with my build class, and then it will run this thing. So you can see that it starts InterSystems Iris, it compiles this class util.build, it runs this class, creates the namespace, creates the database. Well, for some reason it doesn't tell when it does it. And then it just stops the container. Just one last bit that we have to add before we can start the container is the Iris license file. So I'll create a new config directory and write my Iris license file into it. And this is the actual command that starts the container. So we now have container image in our local image repository, which we make with docker build command. And this will actually start the container. It will give it the name test. It will publish 52773 port, S port 52773. Those two commands, the volume for configuration and the volume for external data. It is very imperative to understand that container itself doesn't have a storage. So it only lives while it's live here. When you stop the container, it will destroy all the data that you might put into it. When you start it again, it will start fresh. So if you want to save anything, you have to map those things into external volumes. So we map our configuration with the Iris key, and we map this external volume, and we provide Iris via this parameter IC data directory an instruction to store all the configuration database in that volume. So now if we will run this command, just notice how fast it actually starts the new instance of cache. So now if we will check what is running, what kind of containers we have running. So we created this container 6 seconds ago, and it is listening on port 52773. If I will now go to my port 52773, which is this one, I'll refresh it. I see that now I have a new instance of my application running on this port. So for example, if I will try the same thing on port 8000, it is still not available. I will start it a little bit later. Just for you to see how the data preservation works. So I can choose the environment name here. This environment is named Bark Health Development Environment, and this one will be just test 1 to 3 or something. So it will save this value in the database. When I create a new container here, so this is my test container. It has name test, and I will do the exactly same thing with name prod and port 8000. So it started. Now I have 2 running containers, and if I refresh this one, well, if I wait a little bit until it will start and refresh this one, so you can see that database is still empty. So I have a separate database with test 1 to 3 here, and this one is my production environment with an empty database that I just started. It takes really it is very fast to create a new environment using containers, as you can see. And the trick is you can not only use this stuff to create new environments on your local machine, you can use the same thing to send container to the cloud. So those 2 commands, docker tag and docker push, will actually push my container into the Google container storage, which I created just for this presentation and named JS 2018 Modernize. I will not really issue the docker push command because it takes a while to send stuff into the cloud. But I will show you how to create this container on the cloud in real time. So all I need to do is go to my Google Cloud platform setup and click this button, create. Well, no, I don't want to do this. Yeah, so it will show me this page. I will leave everything by default, so I will have 1 CPU with 4 GB of memory. All I need to do is just click this container thingy and paste name of my container from here into that field. That's it. That's all configuration I need to do to put my application, the traditional application that was built using Cache 2017, into cloud. So I click this create button, and it creates the instance on the Google Cloud with my application in it. So it does take a while. What I wanted to show you next is how we can upgrade an environment. So if we will go back into my development environment, can you see a bug here? Well, it's right there. This one. So I want to fix this bug. So I go into my atelier. I find the bug. I think that's it. And I fix it. And I will name this Bark.ai version 2. So I save this stuff. Okay, get lost. I save this stuff. I refresh this page. Well, My session has expired again. So now I have no bug. I have Bark version 2 on my development environment. It's all good. I still have the old stuff on my test and production environments. So what I need to do is I need to go back, copy this database to my working directory, and run the build command again. And this time I don't change anything, so it's all already done and set up. I just run this build command. It will go into my iris, run this build class. It will stop iris. Stopping iris takes much longer than actually starting it. So yeah, well, it's success. So now I have a new version of my application in the container. I still didn't deploy it. So after I did that, I still have my old containers running in production and in test. So what I need to do now is to change the container, for example, in test environment. So I will create this new container, test new. It is pretty much the same definition as previous container, except this part. So I take my volumes from the old test container, and I will use them for my test new container. This way, I will preserve my mappings for my databases and for my configuration. So I run this. So when I do Docker create, it actually doesn't start the container. When we do Docker run, it creates and starts container. When I do Docker create, it just creates it. So now I can stop the old container and start a new one. Again, it doesn't take long. Stopping container does take, for some reason, longer than starting it. So this means that my container test was stopped. My container test new was started. And if I go to this environment, you can see that there is no bug. But this is Bark version 2. And I still have all my data available that I said before. But now, let's say I didn't like it. I like it with bug more. So I want to revert to my previous version. With containers, it's really simple. It might be quite difficult without containers. But with containers, I just stop my new container. Well, it takes a while. And I start my old container. So this means that old container has stopped. New container has stopped, old container has started. I go here, refresh it, and I have the old version. So it's electronic path record version 1, and bug is back. So if we will go back to our Google Cloud, okay, hide info panel. It actually started this VM. It assigned it an external IP. And now if I will use this external IP instead of my 127.0.0.1, sorry, the wrong key. Let's try again. Copy this and paste it here. So now this is actually accessible worldwide in a Google Cloud. Well, that actually concludes my demonstration. Yeah, it's time for you for your little presentation. Please welcome Ben from InterSystems.
At InterSystems. InterSystems is a software development company that specializes in receivables management software. And we've got a long history of your traditional premise applications where they're the big monolithic applications, and we worked in a number of industries and so on, and have these premise applications, and we even host some of them in a variety of data centers and such. But for the last few years, we've been working on moving toward the cloud and with cloud-native applications using microservices architecture and trying to take advantage of a lot of these technologies like he's been showing off today. And so we've been doing that for the last several years and having some pretty good success with it. And so they asked if we could share some of the benefits that we've been able to recognize from our use of containers. Now, one of the first advantages that I'd like to mention is the portability of it. Because it is so easy to move around, and it is exactly what you build it to be, as he demonstrated, where he built it in his dev environment and then moved it and deployed it in another local environment, deployed it in the Google Cloud. By having it in such a sort of containerized way where it's so portable, it's so easy to, for example, start and stop projects, move developers from one project to another, because when they need to get started on this new thing, well, you just hand them the container, they run it, and they've got their local dev environment all up and running. Or, if they need to do some local testing, it just makes it super easy to move back and forth that way. And we also have actually found some cost savings because of how easy it is to start and stop and how portable it is, where before, if you had a developer working on 2 or 3 projects, they probably had 2 or 3 development environments running all at the same time, and they might need multiple machines to do that. Or maybe you're running QC environments somewhere in a cloud, and you need lots of those environments to do different things. Maybe you need to do perf testing in one and functional testing in another, and you're trying to get out that other release on that branch over there. With containers, we're able to spin those up and shut them down as we need them. We can turn them off at night if we want to. We can turn them back on in the morning. And we're actually able to do all the same work and maybe even more with less compute power, because we're able to run whatever we need to at any given time and shut it off, and it's right there in exactly the state it was when we bring it back. The other thing that's kind of obvious about this, in my perspective, is just the speed with which you're able to deploy it. Because you're able to do so much sort of pre-install work, at build time. With a traditional app, you would have to deploy the server, and you'd load Iris or Cache or whatever on there, and you'd have to do your install, and you'd have to do your code compile, and you'd go in and set up all your configuration. Well, all that stuff happens now at build time. And so at the time that the dev has made their code changes or whatever, and you're building it, you can pre-install everything, you can pre-compile everything, you can set up all your namespaces, get your configuration exactly how you want it. And then you're basically capturing an image of that with your container image, which then you can deploy just anywhere in a matter of seconds. And so it just makes it super nice. For example, when we, in our continuous integration pipelines, when we need to run our unit tests, we have a build node, we spin up the container, run the unit tests against it, shut it down, and we've got the exact results of that with really fast feedback back to the developers. It also makes it where we can scale out or scale in as needed in our production or testing environments to manage the load or the whatever testing we want to do. You can just scale it out and then scale it back in as needed. And then the other thing is the consistency that it provides, where you've always heard the things where the QC folks get a particular new release and they test it and they say, well, I found this bug, and the devs say, well, it worked in my system. Well, now the QC systems are running exactly what the devs are running, which is exactly what you're going to run in prod, because it's exactly the same container, and it's configured exactly the same way, it's managed exactly the same way, and so you're running the same thing out through all your environments. And then it fits really well with, as we've been doing these applications and trying to do these in a modern way with microservices, it fits really well with that whole infrastructure, because we've been working on continuous integration pipelines, continuous deployment pipelines, and with their microservices, you want to take small bits of code and deploy them quickly and iteratively and often, as opposed to, I want to do a giant release once a year or whatever. This makes it so that you can do that simply, you can do that easily and quickly. And then you can start thinking about things like, or maybe I want to do a rolling update because I want to have a 24/7 system. And so I maybe have a couple of different systems. For example, I could set 2 or 3 of these applications running my application code behind a load balancer, have those with maybe an ECP map back to a database server or something like that. And I could take those servers, take them out of the load balancer, replace them with another one, with another container, one at a time, and I've done a completely live on rolling update with an upgrade of my software. So you can start doing things like that and think about that, and you can do those on a frequent basis. You can start doing your upgrades every day, in the middle of the day perhaps, to live production environments. And so there's just a lot of power that this sort of technology can bring with it.
All right, thank you very much for your insights. If you want to learn more about microservices, there is this Experience Lab presentation tomorrow and on Wednesday. Please come and try to break your monolithic applications into microservices. So once you have it in container, it's much easier. And then please complete the survey in the event app. Go visit us in Text and Change. Talk to me if you want to learn more. I'm happy to help, or talk to Luca. If you have any questions, please ask. There is a mic up there. Thank you.